Hello friends, in previous video I have discussed about the concept of polarizer and the Malus law. In this video I am going to discuss about the semiconductor and its types. In general, we know what is meant by an semiconductor. So it partially conducts the current, right? The two semiconductor materials are available. One is about germanium and another one is silicon. So these are the two semiconductor materials. So here we are going to discuss about the semiconductor and its conductivity and how it can be classified and what are the types involved in the semiconductor concept. So, semiconductor or the class of material which partially conducts the current. So, here the conductivity can be controlled and manipulated in many technically interesting ways. And here they have filled a valence band and an empty conduction band with a band gap of less than a 2 electron volt. So here the semiconductors are classified into two types. One is intrinsic semiconductor and another one is extrinsic semiconductor. So intrinsic semiconductor can be otherwise known as pure semiconductor and eccentric semiconductor is otherwise known as impure semiconductors. So here the impure semiconductor is classified into two types. One is a p-type semiconductor and another one is a n-type semiconductors. So first type is intrinsic semiconductor. So here the semiconductor which is pure and it does not contains any impurity materials. So here the number of free electrons and the holes are equal. So a common example of these type of semiconductor is pure germanium and silicon. So here the forbidden energy gap is so small that is even when compared to an ordinary room temperature. There are many electrons which possesses the sufficient energy to cross the forbidden energy gap and enter into the conduction band for the process of recombination. After the recombination process, it starts emitting the photons, right? So the next one is about the eccentric semiconductors. So here the eccentric semiconductor contains the impurity of the materials with a valence band higher or lower than the valency of the pure semiconductor added, so that there may be increasing in the electrical conductivity of the semiconductor. So here the extrinsic semiconductor is classified into two types. One is n type and another one is p type. In n type, when a small amount of pentavalent impurity material such as arsenic is added to a pure germanium crystal, which results in a resulting crystal is called as the n type. For a p type, we are adding a small amount of a trivalent impurity such as indium, boron or gallium is added to a pure semiconductor crystal. So the resulting crystal is known as p type semiconductor. So here the diagram shows the difference for n type and the p type. So here in n type we are using the pentavalent impurity is going to add with the pure semiconductor devices, which results in the donor impurity which contributes the free electrons to move from that crystal. So this is about your n type. In p type, it accepts the impurity and creates a hole in that. Fine. So here we are using the trivalent to getting added with the pure semiconductor materials. So here is a few difference between the intrinsic and eccentric semiconductor by considering a certain factors like purity, density, electrical conductivity, temperature effects and the impurities. First factor is about a purity of the semiconductor. So here intrinsic is very pure semiconductor, eccentric is impure. While considering about the density of the electron, here the electrons and holes are equal, but in eccentric it is not equal. Electrical conductivity is low in intrinsic semiconductor, where in eccentric the electrical conductivity is high. In going to the temperature concept, here it depends upon only the temperature, but in eccentric it depends on the temperature as well as the amount of impurity we are adding to that pure semiconductor materials. Next upon impurity, there is no impurities are added, but in eccentric we are adding the trivalent and the pentavalent. for n-type and p-type. So this is the difference between the intrinsic and the extrinsic semiconducting materials. So the next one is about the semiconductor statistics. So here we are going to calculate the density of the states. Why? Because here the density of electrons and holes are equal in intrinsic and it is not equal in extrinsic. So for that concept we are going to determine the density of the state. So here the many important properties of semiconductors are described by considering the electron in the conduction band and holes in the valence band. So here the density of state can be represented by G of E. Fine. So here it represents the number of electrons in the state in band per unit energy per unit volume of the crystal. So here we are using the quantum mechanics to evaluate the density of state. Fine. So according to the quantum mechanics, we know according to the quantum mechanics E is equal to h nu. So here we are considering the three coordinates. So I am rearranging the equation to E is equal to h square divided by 8m L square. In that bracket we have to consider all the three coordinates. So nx square plus ny square plus nz square. So I am rearranging that equation entirely, that is equal to n. So n square is equal to nx square ny square plus ny square plus nz square. So I have rearranged that equation and I am going to find the value of n over here. So n is equal to square root. I am just rearranging that equation to find the value of n. So while rearranging, I will get n square is equal to 8m L square E divided by h square. Later on that I am determining the density of state based on the energy and the n values. So here E determines the forbidden energy gap. So E is minus Ec for the electrons in the conduction band. Fine. And here the graph indicates that when there is losses of energy starting, automatically density of state get mutually increase and it reaches the saturation point over here. So this is about the semiconductor statistics density of the state. And the next topic is about Fermi dielectric functions. In the next video, I will discuss about the topic. So in today's video, I have discussed about the semiconductor concept and how it can be classified and what are the types involved in the extrinsic semiconductors and classification of intrinsic and extrinsic semiconducting materials and the density of state. Fine. Thank you.